In the last session, we were discussing the effects of the force and acceleration, and just recall the idea that whenever object is at rest or it is moving with a constant speed, so what we can say that the resultant force, there will be forces, but the resultant force will be zero, or no resultant force will act on the object. And whenever object is accelerating or it is decelerating, then there will be a resultant force act on the object. If it is accelerating, then the direction of the motion, the direction in which the object is traveling, and the direction of the resultant force will be same. But if it is decelerating, the direction of the motion, the direction in which the object is moving, and the resultant force will be opposite. So the black arrow is representing the direction of the motion, and the red arrow is representing the force, the resultant force. So when the resultant force and the direction of motion are same, that object will accelerate. And if the resultant force which is acting on the object is opposite to the direction of the motion, that object will decelerate. And recall the formula. Whenever there is a resultant force and object is accelerating, the formula which relate force, mass and acceleration, F is equals to ma. Force is equals to mass multiplied by acceleration. So now we'll do questions related to the topic which we discussed yesterday about effects of the force and acceleration. Some of the questions we already discussed yesterday. In question 7, a force acting on a moving ball causes a motion to change. This force is constant, force is not changing. What makes a force produce a greater change in the motion? Greater change in the motion means greater acceleration. So how we relate the formula which relate force, mass and acceleration? We have the formula F is equals to ma. Force is not changing, or we can also say F divided by m is equals to a. So in the question they mentioned the force stays constant. So this F is not changing. We want to increase, we want a greater change in the motion, we want to increase the acceleration. So if I want to increase the acceleration, what I should do? I should reduce the mass of an object, because if I reduce the mass, the acceleration will increase. So what could be the right answer when we check the options? The first one, decrease the total mass of the ball. That's true, because if we reduce the total mass, it will have a greater acceleration. So in this example, A will be the right answer. Increasing a temperature, temperature does not have effect on this motion of the object. Use the ball with a hollow center but with the same mass. Hollow center means like it is hollow at the center but the mass is same. You're not changing the mass. If you're not changing the mass, like two objects are there, you're using the same force and you're using the same mass, so they will have the same acceleration. So that will not affect. Use a different material so that we'll have a lower density and same mass. So if you're keeping the mass same, the acceleration will not change, because the force is constant, mass is constant, so acceleration will be constant. Is it clear why A is the right answer for this? We have the formula F is equals to ma, force is equals to mass multiplied by acceleration. So acceleration is force divided by mass. If we want to increase the acceleration, we want to produce a greater acceleration, then what we should do? We should reduce the mass. That's why A is the right answer for this. Moving on to the next question. An object decelerate from 25 meter per second to 5 meter per second in 4 seconds, and it has a mass of 50 kilogram. What is the resultant force? So to get the resultant force F is equals to ma. We have the mass, but we don't have acceleration. So what we will do, first we will find the acceleration. How we'll find the acceleration? If you remember the formula for acceleration, acceleration is change in the velocity divided by time. So A is equals to V minus U divided by T. The object decelerates from, so this is a starting speed. The starting speed is known as U, and it reduces the speed to 5 meter per second, so that is V, and the time it took, it's 4 seconds. So when we are calculating the acceleration, it is V minus U over T. So 5 minus 25 divided by time, that is equals to 4. 5 minus 25, that is equals to minus 20 divided by 4, and minus 20 divided by 4 is equals to minus 5. Why we are getting a minus 5? Negative sign shows this object is decelerating or slowing down. When we are finding a force, F is equals to ma. So m is a mass, which is 50, multiplied by deceleration, which is minus 5. So 15 to minus 5, we are getting minus 250. What negative sign shows? This negative sign for a force is showing that the direction of the motion and the direction of the force are opposite of each other. That's why we are getting a negative answer of the force. And the value of the force is 250. So C is the right answer for this. Is it clear? Question 8. To everyone. Then another question, a resultant force of 4 newtons. So we have the force acting on the mass. So we have the mass, and it is acting for 3 seconds. We need the change in the velocity. What is the meaning of change in velocity? It is denoted by delta V, which means V minus U. So first, again, we'll use a formula which relate force, mass, and acceleration. So we have the formula F is equals to ma. Force is equals to mass multiplied by acceleration. So force is 4 here. The mass is 0.5 and acceleration we don't know. First we are finding the acceleration. So 4 divided by 0.5, so 4 divided by half, that will be equal to 8. So acceleration is 8 meter per second square. Then in the question, we don't need acceleration, we need change in velocity. And how we can relate the acceleration with the change in the velocity? We know that acceleration is equals to final minus initial divided by time. So in the question, we need final minus initial, or we need V minus U. This is what we need. A is the acceleration, that is 8. T is the time, that's 3. And it is V minus U, or change in velocity. This 3 is divided here, other side it will multiply. So 8 multiplied by 3, that will make 24. So 24 meter per second is equals to V minus U, or we can also say the change in velocity. So option D is the right answer for this. Is it clear? This question? Question 9, in which we worked out the relation between force, mass, and acceleration first to get the acceleration, and from acceleration look, if you check the question, in the question, first, whenever a question is given, you should highlight what is given to you, what values are given. The resultant force 4 Newton, so F is given. An object of mass 0.5, so mass is given. 3 second time is given. And what they're asking, what is the change in the velocity? What is the meaning of change in velocity? It means V minus U. So how you can find V minus U? You have the formula A is equals to V minus U over T. So you have T, but you don't have A. And how you can find A? So first use the formula which relate force, mass and acceleration. So F is the force, M is the mass, and A is the acceleration. A force of 4 Newton is acting, so you write 4. The mass is 0.5 and acceleration is A. 0.5 is multiplied here, other side it will divide, so it will be 4 divided by 0.5. 4 divided by 0.5 or 4 divided by half, that is equals to 8 meter per second square. So acceleration is 8 meter per second square. But in the question they are asking V minus U or change in velocity. So you have the formula A is equals to V minus U divided by T. Now we have A and we have T, so we can find V minus U. So A is the acceleration 8, V minus U is unknown, and T is the time. According to the question it is 3. So if 3 is divided here, other side it will be multiplied. So it will be 8 multiplied by 3 is equals to V minus U. 8 multiplied by 3 is 24. So it means the change in the velocity is equals to 24. That's why D is the right answer. Is it clear, this part? Normally you will find in paper 4 the questions are interrelated, so it's not like a direct question about force and acceleration. It is related with different parts. Example, a speed time graph is given. A speed time graph is given, and keep in mind the slope of speed time graph represent acceleration. So it is first a straight line and then it is a curve. So first it is a straight line and then it is a curve. So if I say these letters A, B and C, so what is the acceleration from A to B? Acceleration from A to B. The slope represent the acceleration for a speed time graph. It's a straight line. So what we can say about acceleration from A to B? Is it zero, constant, increasing, decreasing? So speed time graph, the slope represent acceleration. So from A to B, it is a constant acceleration. So we have the formula. Look, you have the formula F is equals to ma. Normally the mass of object does not change. Some cases it may change, like sometime evaporation happens, so the mass change. But normally most of the time the mass will remain same. So if mass is constant and in the question acceleration is constant from A to B. So what happened to force? The force or resultant force, that will also remain constant. So if acceleration is constant, the resultant force will be constant as well, or resultant force will not change. But what happened from the term constant means it's not changing. So what happened from B to C? What happened to acceleration? From B to C, is it increasing, decreasing, constant, or zero? From point B to point C, the acceleration. Acceleration is increasing, decreasing, constant, or zero from B to C. If you have a speed time graph, if the curve is going up, slope is increasing for a speed time graph, and the second possibility, the slope might decrease. So here this means that acceleration is increasing, and this one means acceleration is decreasing. So what happened from B to C? From B to C, the acceleration. So from B to C, the acceleration is decreasing. So if the acceleration is decreasing, you have the formula F is equals to ma. Force is equals to mass multiplied by acceleration. Mass of an object most of the time does not change until unless, like for example, if there's a fuel inside the car, then the mass will change, but more or less the mass will remain constant. So what happened if the acceleration is decreasing? So what happened to the resultant force? The resultant force will also decrease. As we know, force and acceleration are directly proportional. So if the acceleration decreases, the resultant force will also decrease. If acceleration increases, the resultant force will increase. And if acceleration is constant, resultant force will be constant. And the last one, acceleration is zero, the resultant force will be zero. This is just a theory about the question. Now we'll move to the question. The first part, calculate the mass of the car is 1200 kilogram. Calculate for the first 20 seconds of a motion the distance travel. So speed time graph, how we calculate a distance travel. So speed time graph, area under the graph will give us the distance travel by the object. So what shape it is making? A speed time graph, distance travel is equals to area under the graph. So what it is making? It is making a triangle. And what is the area of the triangle? Half base into height. So in this case, it will be half. The base of this triangle is 20, and the height, it is, each box is representing 0.5, so it is 11, 12, 13. This is 11, 12, and 13. So this looks 13. So I'm taking as 13. So it will be half base into height. So half 20 into 30. So when we simplify 10 into 30, 13, it will be 130 meter. If the speed is in meter per second and time is in second, so it will be 130, and the final answer will be meter. The second part, acceleration of a car, again acceleration for first 20 seconds. How we can calculate the acceleration? If it's a straight line, we'll use the formula V minus U over T. So starting speed is 0, final speed is 13, because they're asking for first 20 seconds. That's the first part, first 20 seconds. We need distance and we need acceleration. The final speed was 13 and the time interval is 20 seconds. So acceleration will be 13 minus 0 divided by 20. So it will be 13 by 20. What's the answer when 13 divided by 20? It is 0.65 meter per second square. Because it is acceleration, so meter per second square. If it was a speed, then it is meter per second. Is it clear, the first two parts, A1 and 2? Then the resultant force. How to get the resultant force? The distance travel we already calculated. It was 130. Acceleration was 0.65 meter per second square. They mentioned the mass of the car is 1200. We need the resultant force. So resultant force F is equals to ma. Mass is 1200 for this car multiplied by 0.65. So 1200 multiplied by 0.65. What is the resultant force? Multiply them. 1200 multiplied by 0.65. So it will come out as 780 Newton. That is the resultant force acting on the car. So you can see that topics are interrelated. The first part was related to the motion, the first two parts, and the third part is related to the resultant force. Then describe the motion of a car from 25 to 40 seconds. So what is happening from 25 to 40 seconds? How we explain this motion? So as we discussed earlier that its acceleration is decreasing. You cannot say deceleration. Deceleration means the speed should also decrease. So we'll use the term acceleration is decreasing. What does it mean acceleration is decreasing? Like for example, the speed was say 13 meter per second when time is equals to 0, example, or time is equals to 25. Then the speed is say 18 meter per second when time is equals to 35. So 15 time is equals to 30, and here example it is 20 meter per second when time is equals to 40. So when we calculate the acceleration here, the speed is increasing, speed continue to increase, but what happened to acceleration? Change in velocity divided by time. So it will be 18 minus 15 divided by time interval, that's 5. So 18 minus 15, that is 3 divided by 5. So 3 divided by 5, that is equals to 0.6. So here we will have an acceleration of 0.6 meter per second square. But when we check the second part of the motion, the final is 20, initial is 18, and time interval is 5. So 20 minus 18, that's 2 divided by 5. So it is 2 divided by 5, that's equal to 0.4. So even though the speed is increasing, but the change in speed, even though the speed is increasing, but the change in the speed is decreasing, that's why we call that as acceleration is decreasing. Saim, which part you are not able to understand? You can use the mic, specific part you are talking about. About the acceleration decrease, the question is describe the motion of the car in the period of a time 25 to 40 seconds. If, as we discussed in a speed time graphs, for a speed time graph, if it is a straight line, what we call that as a constant acceleration, means constant change in the speed. If the curve, the slope is increasing, the gradient or the slope is increasing, what we call that? We call that the acceleration is increasing. And if the slope of a speed time graph is decreasing, So what we say about this, we say that acceleration is decreasing. So in the question, they ask, explain the motion of this car from 25 seconds to 40 seconds. So from 25 to 40 seconds, when we check the graph, the shape of the graph, so which one it matches with? This shape. Constant acceleration, increasing acceleration, or acceleration is decreasing? Yes, sign. Which one it match with? So acceleration is decreasing. That's why when we write the answer in the last part, we will say that acceleration is decreasing from 25 seconds to 40 seconds. Is it clear? So that was a question and it's of only 1 mark. So you just have to mention that acceleration of the car is decreasing from 25 seconds to 40 seconds. Is it clear now? Okay, another question. Why we cannot say deceleration? What is the reason? Because the term deceleration means the speed is also decreasing. If you have a graph like this, in which the speed is also decreasing, these type of graphs in which the speed is decreasing, what we call that as deceleration. So acceleration decreasing does not mean the speed is decreasing, but the change in the speed is decreasing. In question 3, an object is moving in a straight line with a constant speed. So there is an object which is moving in a straight line, like this is the direction of the motion, and it was moving with a constant speed. So if it is moving with a constant speed, right now what is the resultant force? The resultant force is 0. There is no resultant force because the speed is constant. Now in the question they ask, now the resultant force began to act. So this object was moving with a constant speed and now there is a resultant force acting on the object. State the ways in which the force may change the motion. So how the force can change the motion of this object? For example, if the resultant force is same as the direction of the motion, what will happen to this object? Will it accelerate or decelerate? If the resultant force is acting, initially the object was moving with a constant speed. When there was no resultant force, now they are saying there's a resultant force acting on the object, same as the direction of the motion. So what will happen to this object? It will accelerate or decelerate? If the direction of the motion and the direction of resultant force are same, what happened to the object? Will it accelerate or decelerate? So as the direction of resultant force and motion are same, this object will accelerate or its speed will increase. And what is the second possibility? What might happen if the direction of the motion and the direction of the resultant force is opposite? So what happened to this object? This object will decelerate. So we have to write the answer in words here. Yeah, the car will slow down or the object will decelerate, or because in the question they mention an object. So how we write in words, we'll mention simply that when resultant force and direction of motion are same, the object will accelerate or the speed will increase, and opposite will happen when the resultant force and direction of the motion are opposite of each other. The object will decelerate. Is it clear? You don't have to draw the figure in exam, you just have to write the answer, and it's of 2 marks. So one is for showing that it will accelerate when they are in the same direction, you will get the 1 mark, and if it is opposite it will decelerate. State one other effect of the force that could have on the object. So we discussed the effect of the force. The force can change the shape or size of an object, force can change the direction of the motion, or force can change the speed of an object. Already one of the effect they mentioned that force can change the speed. So what is another effect? It can change the shape or size, you can mention. That's a second effect you can mention. One is already they mentioned. So it can change the shape or a size of an object, or it can change the direction of the motion. In part C, the mass of a car is 1400. The car is initially at rest. So starting speed, when something is at rest, the starting speed is 0. Is moved along a level road and the resultant force of 3500 is there. The car reaches a speed of 30 meters per second, so that's the final speed. So we have the force, we have the mass. Calculate the average acceleration, total acceleration, final acceleration, initial acceleration. All have the same acceleration. You can find by two formulas. One is F is equals to ma. Another one is final velocity minus initial divided by time. So which formula I should use? I have to check what is given. I have v, I have the final velocity, I have u, but I don't have time. So I cannot use this formula right now. I have the force and I have the mass, so I can use this formula to get the acceleration. So F is equals to ma, 3500 is the force. The mass of the car is 1400 and acceleration is a. 1400 is multiplied, other side it will divide. So 3500 divided by 1400. What is the final answer for acceleration? 2.5. So acceleration of this car is 2.5 meter per second square. Is it clear, the first part? That we use F is equals to ma because we cannot use A is equals to V minus U over T as we don't have the time interval. The second part, calculate the time for which the force is applied. So now we can use this formula to get the time. We have the formula acceleration is V minus U over T. So we have the final velocity, we have the initial, and we have acceleration. So we can find the time. So when we solve this, A is equals to V minus U over T. A is the acceleration, which is 2.5. We already calculated in the previous part. V is the final velocity, that is 30. U is the initial velocity, that is 0. And T is the time, we don't know, we are finding it. So when we further simplify, it will be 2.5 is equals to 30 minus 0, which is 30, divided by time is T. So T is divided here. T is divided here, other side it will be multiplied. So it will be 2.5 T is equals to 30. And we need T, so 2.5 is multiplied, other side it will divide. So 30 divided by 2.5. 30 divided by 2.5. That will be 12 seconds. So this force acting on the car for 12 seconds. Then state the name of the force which oppose the motion. What we call the force which always oppose the motion. There is a specific name. So we call that as a friction. That's right. The friction is a force which always oppose or try to oppose the or resist the motion of an object. Is it clear? Discussion part C. Reason why you can not write resultant force, because resultant force is not always oppose the motion. Some cases it is opposing the motion, some cases it is same as the direction of the motion. But the friction is always opposing the motion. That's why resultant force is not the valid answer here. It should always be a friction force. Because resultant force can have both possibilities. It might be in the same as direction of motion, or it might be opposite to direction of the motion. So you can mention friction, you can mention air resistance, or drag is also a word which is a term which is also used for forces opposing the motion. So these are some questions related to force and acceleration. I'll share another link and continue this discussion about force and acceleration.